Okay, so this video is going to be on Hopital's rule.
Hopital's.
Well, yeah, however you pronounce it. This rule is really good for finding the limits of things if you have a limit where you're either getting 0 over 0 or infinity over infinity.
So one of the most common examples is when you try to take the limit of x goes to 0 sine x over x, and what you get is, when you plug the numbers in, is 0 over 0. Now what Hopital's rule is that when you get an answer like this, 0 over 0 or infinity over infinity, you can take the derivative of the numerator and the derivative of the denominator separately, and the limit of the resulting fraction will be equal to the limit of the original. So this problem actually equals the limit of, as x goes to 0, we can just take the derivative of the numerator and the denominator. We get the limit as x goes to 0 of cosine x over 1, and cosine of 0 of course is 1, so the limit equals 1. That's a fairly simple one. They can get a bit more complicated. For example, limit as x goes to infinity of x cubed over e to the x. Sometimes you have to do them more than once to get the answer, but you can see if we just plug in infinity, it's of course infinity over infinity. But that tells us that we are able to use Hopital's rule, because if it's, you can only use this for these two cases. If it's 0 over infinity or infinity over 0, that doesn't work. It has to be one of these two cases. So this is going to equal the limit of the derivatives 3x squared over e to the x. Now you can probably figure out that it's going to be 0, because the e to the x will stay the same and the numerator will diminish, as shown here. And that's going to equal 0 because we have infinity on the bottom and a constant on top. Now sometimes these aren't so easy to spot. Let's take the example of the limit as x approaches 0 from the right of 1 over x times the natural log of x. Now you may be thinking that we can't do this one with Hopital's rule because there's no term in the numerator. It only has a denominator with an x term. But we can do a little trick and rewrite this. So rewrite this as the limit as x goes to 0 of 1 over x over natural log of x, which is of course equal because all we did was made it a complex fraction, but we can do that now. And if we plug these in, we get infinity over infinity, or negative infinity over infinity, which also works. So now we can apply Hopital's rule to this problem. We get the limit as x approaches 0. Derivative of 1 over x is negative 1 over x squared, and the derivative of natural log is 1 over x. So now we can simplify this a bit by canceling some x's. We end up with limit as x goes to 0 of negative 1 over x, and when we approach 0 in the denominator, the answer becomes infinity. Since it's negative, the answer will be negative infinity. So those are a few examples of how you can effectively use Hopital's rule.